Hey, Miss Marion here. We are doing Unit 7, Lesson 3 and 4. Yeah, we're doing 3, 2, 3, and 4 together, so 2 lessons because they're a little bit shorter. We are going to start with a starter, so we do have these questions. Go ahead and write those down and find the answers to these. This is a review to go ahead and get us ready for the end of year level tests. And so write these down, answer them, and then come back to me and we'll do them together. All right, so let's go ahead and remind ourselves. We want to go ahead and make it so that letters are on one side, numbers are on the other. So we want to go ahead and make the 10 come over here. So remember that 10 is positive. So because it's positive, we need to subtract 10 from both sides. We're going to bring down the minus 6v equals, and then negative 104 minus 10, put it in your calculator exactly how it looks, is going to be negative 114. So then negative 6 and v, remember they are multiplying. So we are going to divide by negative 6 on both sides. So negative 114 divided by negative 6 is positive 19. So v is going to equal 19. All right, number 2. Number 2, negative 13 wants to be over here with his friend. So how do we move that negative 13? We're going to do opposite. We're going to add 13 to both sides or give it a positive. So we have negative 9x equals negative 103 plus 13 equals negative 90. Okay, and then negative 9 and x are multiplying, so we are going to divide by negative 9. Negative 90 divided by negative 9 is a positive 10. All right, number 3. Number 3 is a little bit different. Remember that we have this out here, so this is the distributive property, where we kind of shoot those arrows. So we're going to say 2 times n is 2n. 2 times 5 is 10, and we have negative 2. Then from here, the 10, a positive 10, wants to be with his friend, the negative 2. So we're going to subtract off 10 from both sides. 2n equals negative 2 minus 10 is negative 12. 2 and n, they are multiplying, so we are going to divide by 2. It's positive 2. So negative 12 divided by 2 is negative 6. So the same thing with number 4, we have the distributive property, hippity hoppity distributive property. So we're going to go negative 2 times 12 is negative 12x. Negative 12 times 5 is negative 60. We're going to have 144. So the negative 60 wants to be over here with the 144. So same things alike. So it's a negative 60. We're going to add 60 to both sides. We're going to get negative 12x, positive negative 60. So 144 plus 60 is 204. Right? Negative 12 and x, they are multiplying each other. So we're going to divide by negative 12. 204 divided by negative 12 is negative 17x, because negative 12 divided by negative 12 makes a 1. All right, so this is number 5 is a little bit different. So first of all, we want to kind of look at it, see how this 8 wants to be over here with the 5. So 8 is a positive 8. So how do we move a positive 8? I'm going to subtract off 8 from both sides. So then I have b divided by negative 4 equals, what is 5 minus 8? That is negative 3. Now, b and negative 4, they are dividing. Opposite of division is multiplication. So we're going to multiply by negative 4 on both sides. Negative 4 divided by negative 4, that is 1. We always cross it out and leave b by itself. Negative 3 times negative 4 is a positive 12. All right, let's go ahead and turn back to page 126. We're going to read the I can statements for lesson 3. I can explain and use a rule for raising a power of 10 to a power. And then we're also going to do lesson 4. Lesson 4 is I can explain and use a rule for dividing powers of 10, and I can evaluate 10 to the 0 and explain why it makes sense. So we're doing lesson 3 and 4 together. Write yourself a sentence, how you feel about that. Also a number, so 1 I don't remember, 2 I kind of remember it, 3 I do remember it, and 4 I can teach it to my friend. All right, let's turn to page 27, and we're going to answer the question, what is the volume of a gigantic cube that measures 10,000 kilometers on each side? Go ahead and answer that question, and then come back to me. All right, so let's think about it. So we have a cube, right? So let's draw a cube. And each side is 10,000. So remember, as if we're doing a volume of a cube, it's length times width times height. So we have 10,000 times 10,000 times 10,000. So we can also say that this is 10,000 raised to the 3rd power, and that's a ginormous number. All right, on page 72, what we're going to do is we're going to talk about powers to a power. Power to a power is what we call it. And so we have this table. And so I want you to complete the table with the information. Notice how here I have 10 to the 3rd raised to the 2nd power. So I have 10 to the 3rd times 10 to the 3rd, which is 10 to the 6th. So go ahead and fill in the rest of the table. There is a part that you can skip if you want, and it's only one part of the table. And then go ahead and do that, and then come back to me. All right, so let's go ahead and go through this. Notice we have 10 times 10 times 10, and then 10 times 10 times 10, 10 times 10 times 10, and then 10 times 10 times 10. So I have 1, 2, 3, 4, okay? So I have 10 to the 3rd, so 10 times 10 times 10. That is 10 to the 3rd. And how many of those groups do I have? 4. And then what is the exponent? Well, it's 10 to the 12th. Sorry, I started with the wrong one. Let's go back up here. 10 to the 2nd. So 10 to the 2nd and then 5 tens. 10 to the 2nd, 2, 3, 4, 5. We know it's 10 that's repeating over and over and over again. And then how many tens do I have repeated over and over and over again? To the 10th. All right, let's jump down and let's do 10 to the 4th, 2. So we have 10, 2, 3, 4. And then we have a second group of it. And so we know that 10 is repeating over and over and over again. How many times? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 10 to the 8th. So the last one, if you've noticed the pattern, this last one is going to be 10 to the 88th power. So where it has power to a power, instead of adding those exponents that we did yesterday, today we're going to multiply those exponents together. So on number 2, again, we're going to write this as far as a mathematical way of actually writing it. So we have 10, we have 10 to the n raised to the m. And what would that be mathematically? We would have 10, and it would be m, n, let's start with n first. So it'll be n times m. All right, let's take the information about the table and number 2, and then let's answer number 3. If you took the amount of oil consumed in 2 months in 2013 worldwide, you would make a cube of oil that is 10 to the 2nd meters on each side. How many cubic meters of oil is this? Do you think this would be enough to fill a pond, lake, or ocean? So how many cubic meters? What is it really looking for? It's looking for volume, just so you know. Okay, go ahead and answer that question and then come back to me. All right, so I like to draw the picture so we can kind of see it. So I have a cube, and it's saying each side is 10 to the 2nd. And remember, volume for a cube is length times width times height. So I have 10 to the second. And how many times am I multiplying that? Oh, that's 3. So the volume is going to be 10 to the 6th power. So would this fill a pond? Would it fill a lake? Or would it fill an ocean? Personally, this would fill a lake. All right, let's turn to page 23 and let's kind of look at some other stuff between Andre and Elena. Andre and Elena want to write 10 to the second times 10 to the second times 10 to the second as a single exponent. Andre says when you multiply the powers with the same base, it just means you add the exponents. So 10 to the second times 10 to the second times 10 to the second is 10 to the 2 plus 2 times 2, which is 10 to the 6th. Elena says 10 to the second multiplied by itself 3 times. 10 to the second, 10 to the second is 10 to the second 3. And these ones you are going to add the exponents, so it's 10 to the 5th. Do you agree with either one of them and explain why? So let's go ahead and let's go through it. Andre, he said that we have 10. He's kind of partially correct. So we have 10 to the second, and it's being multiplied 3 times. He did use the exponential rule correctly. He did multiply the 2 and the 3 together to get the 6. Okay, so writing it down how he wrote it down is not correct, but his final answer is. Now let's look at Elena. Elena, she went ahead and she wrote it down correctly, but she did the exponent stuff wrong. So remember, if we have it as 10 to the second raised to the 3rd power, we actually have to multiply those two numbers to get 10 to the 6th. So I kind of agree with both of them, but only partial, because they're only partially correct as far as the answer. So again, when we're writing things as far as power to a power, we have 10 to the 4th raised to the 3rd power. Again, how would you write that as a single exponent? We're going to multiply those exponents together. So let's go ahead and let's turn to page 27. On page 27, we have this expression. And what we want to do is we want to evaluate the expression. What does evaluate the expression means? I want you to find the actual number to this answer. So go ahead and work through that, and then go ahead and come back to me on that. So the answer to this is actually 1. All this is going to equal 1. Okay, well, how do we do this? If I multiply 2 to the 5th, okay, and we're going to put it in our calculator, 2 to the 5th times 3 to the 4th times 3 to the 2nd. And we're going to get 23,328. Let's do the same thing on the bottom. We're going to do 2 times 3 to the 6th times 2 to the 4th. And we're also going to get 23,328. And if you divide those two, you're going to get 1. So we're going to talk about this a little bit further as far as dividing exponents. We're going to talk about how that actually works. So let's go ahead and turn to page 28. On page 28, we have this table and it's talking about division. And as far as like taking powers of 10 and dividing those, notice the kind of like the pattern that goes along with it. And again, you can skip one of the boxes in the table. And so go ahead and fill in the table and then come back to me and we'll go over it together. So I want to kind of go over the first one. Notice I have 10 to the 4th divided by 10 to the 2nd. 10 to the 4th is 10 times 10 times 10 times 10. And then I have 10 to the 2nd, 10 times 10. And notice how we just have 10 times 10, 10 times 10 as a fraction. And then these ones are there. Okay, so what we're actually, this is kind of a weird way of actually writing it. But remember when we have 10 divided by 10, it makes a 1. 10 divided by 10, it makes a 1, right? That's where this 1 kind of comes from. And then there's 2 10s left over. And then that's 10 to the 2nd. Okay, so let's kind of do it a little bit backwards. So we're going to have it here. So what do we have on top? We have 10, 10, 10, 10, 10. So that's 1, 2, 3, 4, 5. So I'm going to have 10 to the 5th. And it's be dividing by, how many 10s are on the bottom? There's 2. And that's going to be 10 to the 2nd. And then it goes ahead and again, 10 divided by 10 is 1. 10 divided by 10 is 1. We cross them out. We have 3 10s left over. What does that mean as far as exponential? Oh, 10 to the 3rd. Now let's do the next one. We have 10 to the 6th. So we have 1, 2, 3, 4, 5, 6. We have 10 to the 3rd. 1, 2, 3. And again, I'm going to look at it and go, okay, is there anything I can cross out? Same on the top and bottom. So we have 1, 2, 3. How many is left over? There's 3 left over. That's 10 to the 3rd. Is there any pattern that you notice here? Any pattern? So notice how I have 10 to the 6th and 10 to the 3rd. And the pattern that we can kind of look at is if I do 6 minus 3, that is 3. Okay, if I do 5 minus 2, that is 3. And if I do 4 minus 2, that is 2. So notice how I'm taking these exponents, and because it's dividing by each other, I'm going to take the exponent, 43, and I'm going to subtract off the 17. So it's the top minus the bottom, and then I'm going to have 26 left over. So this answer over here is 10 to the 26th power. So here's our table. Again, it says use the pattern to go ahead and find an exponential, like a mathematical expression as far as what we've been doing. So we took the first one, we went 10. We're taking the n and we're minusing off the m. So when we have power to a power, we're going to subtract the first power to the second one. All right, using our information on page 28, let's answer number 3. It is predicted by 2015, there will be 10 to the 10th people living on Earth. At this time, it's predicted that will be approximately 10 to the 12th trees. How many trees will there be for each person? So kind of think about it, answer that question, and then come back to me. All right, so this is kind of weird. It's kind of interesting. So we have 10 to the 12th trees is going to be divided among all of the people. So what we're doing is we're going to take 10 to the 12th, and we're dividing it within all the people, which is 10 to the 10th. And so what will we have left over? We're going to have pretty much, we're subtracting off the 2 exponents and get 10 to the 2nd. There will be 10 to the 2nd trees per person. All right, so let's look at page 29. So we're going to go through some questions, kind of about talking about our 0 exponent again. So on number 1, it says, write 10 to the 12th times 10 to the 0 with a power of 10 with a single exponent using the appropriate exponent rule. Explain how you know how this is. Okay, so how would you write that? And then go ahead and come back to me. So remember, if we have 10 to the 12th times 10 to the 0, these are multiplying, right? Remember, we learned this a couple of days ago. We took those exponents, and when they're multiplying, we're going to add those together. So we're going to say 12 plus 0. We're going to have 10 to the 12th power. So remember, when we have 10 to the 0, 10 to the 0, anything raised to the 0 power is pretty much 1. If I took 10 to the 12th, and I multiplied by 1 is still 10 to the 12th. We get the same answer. All right, let's look at number 2. Write 10 to the 8th divided by 10 to the 0 as a single power using an appropriate exponent rule, and then show your reasoning and what number could be divided by 10 to the 0 to get the same answer. Go ahead and answer that question and then come back to me. So remember, when we have 10 to the 8th, we're dividing these. The exponent rule was 10 to the 8th, and we're going to subtract off the 0, and we still get 10 to the 8th, right? And again, anything raised to the 0 power is 1. So if we took 10 to the 8th divided by 1, we still get that 10 to the 8th, which again is that same answer. All right, number 3. If we want the exponent rules we found to work even when the exponent is 0, what does the value of 0 have to be? We've been talking about this, right? So anything raised to 0 power is always 1. So we're going to go ahead and skip number 4 because of what the questioning is, and so we're just going to go ahead and move on. right? So remember, when we are dividing things, our exponents, 10 to the 36 divided by 10 to the 12th, we subtract those exponents, and then we have what is left over, okay? And then remember, anything raised to the 0 power is 1. So again, our I can statements for today is I can explain and use a rule for raising a power of 10 to a power. That's on page 126. Our other two I can statements on page 127 for lesson 4 is I can explain and use a rule for dividing powers of 10. And I can evaluate 10 to the 0 and explain why it makes sense. So these are I can statements. Write yourself a sentence about how you feel about today. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. Again, today, because we went over lesson 3 and lesson 4, we have 2 sets of practice problems. Lesson 3 and lesson 4. Make sure you go ahead and do that. Hope you have a good day. Thanks. Bye.